This is the second video in the chapter 3.4 linear programming lesson. You were instructed to graph the feasible region and to find the corner points. I apologize if I said there were three. There are actually 4 corner points. Those are the 4 points that bound the feasible region. And it's pretty easy to find what they are. This one is 0, 0. That's always where the minimum is going to occur. That would mean you're making 0 downhill skis and 0 cross-country skis. This one is over 0 up 24, 0, 24. That means you're making 0 downhill skis and 24 cross-country skis. This one is 14, 0 because you'd be making 14 downhill skis and 0 cross-country skis. And then this one is, we suspect it to be 420 if we graphed correctly, but you still need to prove it, and you do that by solving the system of equation. So it's where the blue and the green line cross. So I have solved that system of equations using the elimination method. So I wrote the fabrication equation and the total labor equation here, and I negated the second one so that I had opposite coefficients, and then I solved for x. I plugged it back in and I got 20. So it is 420, but you still need to prove it. So those are the 4 corner points where one of the maximum will occur. It's not going to be at 0, 0. 0, 0 is where the minimum will occur. So the maximum will occur at one of these 3. So on to the next page, which is the second part of the linear programming, is the objective profit, or the objective function. So there has to be more to the problem, otherwise we would be done. And there is. It says the ski manufacturer makes a profit of $40 on each pair of skis, downhill skis, and $30 on each pair of cross-country skis. How many skis of each type should be produced to maximize the profit? So this is known as your objective function, also your profit function, and it's used to find the maximum or minimum profit for a given constraint. So the first thing we have to do is we have to write the profit function, and that's pretty easy. We'll just let P equal profit, and the profit would be $40 for each pair of downhills, that's 40x, and $30 for each pair of cross-country skis, 30y. So we are going to plug each one of those vertices into the profit function, and we're going to see which one yields the maximum amount. So I have listed the vertices here, and actually I have a mistake. One of these should be 14, 0. That one should be 14, 0. So I'm going to fix that. So these are our corner points. The maximum minimum occurs at one of the corner points. The minimum is going to occur at 0, 0. If you make no skis, you're not going to make any profit. So you can see here's the profit function. I plug in 0, 0, and my output is 0. And then I'm going to plug in 0, 24, and I'm going to see what the profit would be if I made 0 downhill and 24 cross-country skis. So you put in 0 here, and you put in 24 here. 30 times 24 is $720. It's a pretty good profit. Now we're going to see about putting in 14 and 0. So you're making a little more profit for the downhill skis, but you're making a lot less of them. So 40 times 14 is 560. Okay, profit. And now for the last one, 420 is what you put in. This is 160 plus another 600, so 760. So you can see that the maximum occurs here, the maximum profit. So you would maximize your profit. To maximize the profit, the ski company should produce 4 pairs of downhill and 20 pairs of cross-country skis. And that's a linear programming problem. Definitely a lot of steps. So your job for the next video is to complete the linear programming application on the next page. Check your steps and solution using the online Holt tutorial video. The solution is posted there. I also put a video up myself of the solution. So give it a try. It's important that you try, and then check your work. Okay, we'll go from there.